Are you designing solar systems to maximize return on investment by optimizing the design for solar self-consumption? With feed-in tariffs declining and retail electricity rates rising, self-consumption analysis has become critical for commercial solar projects. Today, I'll show you how to import consumption data into PVSyst and analyze for self-consumption for commercial facilities so you can design systems that deliver optimal financial results. Welcome to this training on commercial solar self-consumption analysis using PVSyst. I'm Johan Fritz, and today I'll cover the complete process of importing your commercial clients' consumption data into PVSyst and analyzing their self-consumption patterns to optimize system design for financial performance. The economics of commercial solar have fundamentally shifted. Here's why self-consumption analysis is now essential. Financial benefits. Energy you self-consume directly offsets retail electricity costs, which are typically much higher than feed-in tariffs. Reduced demand charges through peak load offsetting. Protection against rising utility rates, or in other words, electricity costs. Improved return on investment through optimized system sizing. And the commercial advantages: grid independence, reduced exposure to utility rate volatility. Proper consumption data helps size both PV systems and potential battery storage. Maximizing self-consumption often leads to faster payback periods. For commercial buildings with significant daytime loads, designing for optimal self-consumption can dramatically improve the economics of your solar investment. Okay, if you don't have PVSyst yet, you can go to the website PVSyst.com. They offer a 30-day trial that you can just download here and install it. It's about a 500 megabytes download. Okay, so you can just go through the installation step by step. Okay, so it will just say it's in trial mode, and you can say close, and let's start designing our first system. Okay, great, so let's get started. When you open up PVSyst, you will see this screen. So to keep it simple, let's just select a grid connected system. And first thing is to name your project. So let's just call this test project 2. And then you can define your location by clicking here and searching for your address. Okay, and once you've found the area, so just zoom into the specific building you want to put solar on. So let's just select this building as an example and say accept selected point. And you can click here to import the weather data. I think metronome is included by default in PVSyst. And it will show you all the weather data for all the different months. And just say OK, and yes. Okay, great. So we've defined our project name, and location, and weather data. And the next step is to define the actual system. Okay, so let's start with this step, defining the orientation. So here you can define the tilt of the panels and the azimuth or orientation of the panels. So 0 would be south facing. And you've got a southwest facing roof, so 25 degrees looks about right, and your plane tilt, and it's going to be a fixed tilt orientation, fixed tilt plane, and just say OK. So that's your orientation of the panels. Next step is to define our actual system. Okay, for now let's just use a generic example panel of 500 watts. and a generic example inverter of say 9 kilowatts. And let's say we've got 2 MPPTs, and so we need to have 2 strings as well, and we've got a nominal power of 13 kilowatts on a 9 kilowatt inverter, and that's about right. As the DC also always needs to be a bit oversized on the AC, about 20% or more. Okay, and let's just say okay. Okay, so the next step would be to specify our losses. You can define your thermal losses, ohmic losses, module quality, and so forth. Let's just accept the defaults here, and then or let's just tick something to go to the next step, and then let's define our self-consumption. Great, so there's several options that you can choose here, either no self-consumption or a fixed constant consumption. So amount of kilowatts, constant consumption, monthly values that you can enter here for all the months. So if you've got electricity bills from the customers, you can enter it here. It will not really help to find accurate self-consumption figures, but just totals. Ideally, you would have like to define daily profiles or import values from a CSV file that you measured. So for this example, let's just do daily profiles and do it on a weekly basis. And then once you select that, this tab opens up, and here you can enter your monthly or hourly values for each weekday and for each weekend day. Great, so let's do that now. Okay, so we've analyzed our consumption data from our energy logger, and we've got this power usage by hour, and so this is for week. We started logging at 1 o'clock, and this is weekdays, and then weekend are these 2 days, and then Monday morning at 8 o'clock we took it out again. So let's use this day for a weekday consumption. So you can just get both of it on the same screen, and then manually type over the values from your Excel spreadsheet into PVSyst. Okay, let's just get there again. Self-consumption, daily profiles, and for a week, daily profiles, and working days. So here you just manually type over the values for each hour of the day, 4,450 watts, and the next hour 4,933 watts, and so forth. Okay, great. So now that we've defined our weekly values on the working days, let's define it for the weekend days. And then on your data, just select the weekend days that you recorded and type over the values again. Okay, great. So that's the weekend values defined. You can see the load profile here, and the total monthly energy consumption, and the daily sum of energy used, and the average power used. and just click OK here. And now that we've defined our self-consumption, we can run the simulation by clicking this button. And that runs normally quite quick. So it takes all the weather data and your system design and analyzes the energy generation and energy consumption. Okay, great. So now that we've done our simulation, you can click on this button, Tables, and then select Energy Use and User Needs. And this will show you how much energy is how much of the generated energy is solar energy is self-consumed and how much is exported. So they just click on the table, and you'll see this table coming up. So all the month and the yearly total. So E available is the amount of solar energy that the system generates each month. You can see the winter months is a lot more than the summer months is a lot more than the winter months here in Europe. So this is the energy consumption of the user. This is the amount of energy that's exported to the grid. And this is the amount of energy that's exported, the percentage, and your performance ratio. So you can go here, export, and copy to clipboard, and this will copy the file or the data to your clipboard, and you can go and paste that into Excel and do further analysis and visualization on this data. Okay, so let's just calculate the percentage of energy actually used, or the actual energy, the percentage of the amount of energy that's been produced that's actually used. So we do that by taking the amount of energy used and dividing it by the total solar energy generated. And that gives us a percentage of self-consumption. And we can see that for each month. And you see in total, we've got an energy self-consumption of 75%. So you can change your system and update these figures and then see how much. Okay, if you want to visualize the data, you can just select the solar energy available, the amount of energy that's being used, and the exported energy, and solar energy used. And then just select the totals there. And then go to Insert, Graphs, click on All Charts, and I found the tree map the best way to visualize that. So this will show you the total amount of energy that the user uses, the amount of available solar energy, the solar energy self-consumed, and the amount of energy that's exported to the grid. Great, so let's have a look at some system sizing optimizations to keep in mind. Firstly, if you've got high export rates, you can consider reducing your system size. Unless you've got good feed-in tariffs, then it might be favorable to maximize your system and take advantage of these tariffs. But as I said earlier, export feed-in tariffs are not that great these days. If you've got low self-consumption, then you can consider right-sizing the system to match your actual consumption patterns. So you can consume more solar energy yourself directly during the day and use less from the grid. Then if you've got demand charges on your bill, so if you're being charged per kVA, you can size the system to offset these demand charges and even or move some of these demand loads during your peak solar hour and reduce the maximum kVA that you demand from the grid. Great, so let's have a look at some technology solutions. Obviously, battery storage that can increase your self-consumption by storing excess energy during daytime and then using it in evenings, or even during the day when you've got more usage than you've got production. The excess loads or can be supplied with stored energy from the battery. So it acts as a temporary storage space for energy and then matches your consumption and production better with each other. You can also have a look at load management, so coordinating high consumption activities with peak solar production, putting timers on geysers and washing machines and so forth, to just using it during the peak solar production hours. And lastly, smart controls. You can use building management automation, BMS systems, or home automation systems to turn high consumption loads on during peak sun hours, or even just charge your car, for example, when the solar is available. Great. So in conclusion, system sizing for optimal financial returns. So not too big and not too small, just right to maximize your return on investment. Having access to this consumption data and solar production data, you can optimize your battery storage requirements and see what makes the most financial sense. You can implement load management strategies with building management systems or timers to increase your solar self-consumption. And also, having done these calculations, you can use it in client presentations, and you can optimize the project economics. And the client can see you've done your design based on actual data and not just on guesswork. Great, that's it for this presentation. I hope that was useful and helpful. If you've got any questions, comments, or suggestions, please contact me or leave a comment below. Thank you.